today we're looking at transforming our quadratic graphs. That means making them wider, making them narrower. We're still going to do a translation of flipping them, and we'll still be using the translations of moving left, moving right, moving up, and moving down. So our translations, horizontal, remember that's going to be moving left and right. And to do that, we're going to add or subtract in a parentheses. Vertical, we're moving up and down. Maybe I should move this over here so I can put that on that side just so you can see it there. This is going to be like y equals x plus 3 squared, or y equals x minus 2 squared. So inside the parentheses. Vertical would mean up and down. Y equals x squared minus 3, or y equals x squared plus 4. Those two would again move up and down. Flip is new, and it's just going to take the graph from going opening up to opening downward. And so we're just going to add a negative out front. So, and it works for all of them, so I didn't necessarily, it's not necessarily a dilation, it's more of a translation. But y equals negative x plus 2 squared. That would just flip the whole thing over. It does not affect where the vertex is. That we still find like we normally would. Wider is going to take our normal graph and it's going to spread it way out, kind of make a big U on there. We could also throw in that negative sign in there and flip it upside down. And to do that, we're going to multiply by a fraction. We're going to practice all this as we're going through this today. And in narrower, it's going to make it super, super skinny. And you're going to multiply by a whole number. Technically a number bigger than 1, but we're going to be using like 1 or 2, 3, 4s. Okay, so the first one, we are going to graph this, and your sheet should have a 2 in there. And so we're going to look at this first one that we have, which is just what we were working on yesterday, and this tells us to move it left 2. So I'm going to take my parent function, move it left 2, and then if I'm looking at that graph, I'm going to still do my normal out and up. And just to remember, out and up, it's going to tell me 1, 1, 2, 4, 3, 9. I'm squaring those numbers. And so I can just put those on my graph. And I'll put that 9 in. It's only 1 up above. And then I'm going to switch colors. Now this one here has a 2 up front. And so what I end up doing is I'm going to add a chart onto this table here, and I'm going to multiply by 2. And I take all my ups and I multiply them by 2. So this becomes 2, this becomes 8, this becomes 18. When I'm graphing, I do not graph this one. I now graph my out and my times 2. So I go to my vertex, I go out 1, up 2. And do that both directions. I go out 2 and up 8. And then I have my graph, and it's narrower than my original one. Looking at the next one, I now have a 1/2. So I'm going to go back to my original out and up. We're going to be using these a lot. I'm going to add in a new column, which is going to be a times 1/2. So instead of up 1, I'm going to now go up a half. Instead of up 4, I'm going to go up 2. Instead of up 9, I'm going to go up 4.5. I cross this column out because I don't want to use that. I want to graph just the out and the times 1/2. So from my vertex, I go out 1, up a half. I go out 2, up 2. I go out 3, up 4.5. I'm going to add in my 4, which would have been a 16 and an 8. So sometimes, especially with those decimals, we'll end up needing those higher numbers just to keep my graph accurate. And we can see with all 3 of them on the same point how we can see where one's wider and one's narrower. Those out and up charts are going to become what's really, really helpful for us. The last one, this part here is going to flip my graph. So I go to my same point, and I'm essentially going to do out and down. So we'll just do out, down. And it's still just 1, 1. There's no other number out front. Out 2, down 4. Out 3, down 9. we'd say it opens downward, and it just, the vertex, again, moves the way you normally would, and it's just flipped over. I'm going to go through graphing a couple of these with you. You're going to find your vertex first. So this part here is going to move down 5. There's nothing in the parentheses moving left or right, so I'm just moving down 5. And then I would have my out and up. I know it's an up because there's no negative out front. And then I have a times 3. So my normal. And then I'm going to take my up and multiply it by 3. Cross off my up because that times 3 is my new up. So from my vertex, out 1, up 3. Out 2, up 12. 3, 4, 5, 6, 7, 8, 9. And that's as far as I can get. It's quite narrow. And again, that's going to happen when we have a whole number that we're multiplying by out front. This next one, this minus 4 is going to move right 4. It doesn't move up or down. So I put my vertex on, just like I normally would. This part here is going to flip it. So that means I have an out and a down. And then I'm going to have a times 1/3. So 1, 1, 2, 4, 3, 9. We might need our 4, 16. So we're going to have 1 times 1/3 would be 1/3. 4 times 1/3, which would be 4/3 or 1 1/3. 9 times 1/3 is going to be 3. 16 times 1/3 is going to be 5 1/3. We may have to grab another one. We're just going to cross off that piece here. So I'm going to go out 1, down 1/3. I'm going to go out 2, down 1 1/3. Out 3, down 3. Out 4, down 5 1/3. We're done on that side. I can't go any further on this side, but I still want to look at my other one. So if I did 5, that would be 25, because remember I just square those to get that next piece, and that's going to be 8 1/3. So that should give me enough to get me just a little bit off my chart there. And then I draw it in. So as long as it would fit on that grid, I want to make sure I'm doing this. My last one here tells me to move left 3, and then it's going to tell me to flip. So I move left 3. There's no other number out front, so I'm not making it narrower. I'm not making it wider. I'm just going to do my out and my down, and you don't always have to write just that particular one because it's going to be the 1 1 2 4 3 9. And then we connect our dots. Now we're going to write equations for these. And so writing equations is very similar to when we're graphing them. First thing I'm going to do is look to see if it moves. The first one doesn't move left, right, up or down, but it is narrower. And I can tell by looking at the point 1 1, that's not directly on my graph. However, the point 1 2 is. So it's kind of like I have my out, and it's going to be an up column, and then I have a times something. So I know it's supposed to be 1, but it's really a 2. And then if I look, it's supposed to be 4, so I'm going to look and see it's definitely not at the 4. 5, 6, 7, 8. It could easily be at that 8. Sometimes it's a little harder to tell when they're in there. So that tells me I have a times 2. So we kind of still use those charts to help us. Y equals 2x squared. Our next one, I can tell if I go out 1, up 1, it's on my grids. Out 2, up 4, it's going to be on my grid. So there's no number up front. It's not flipped. It's not moved left or right, but it is moved down 5. Y equals x squared minus 5. The next one, it's moved to the left 4. I can obviously see that. If I do my out 1, up 1, or out 2, up 4, it's on my grids. So I don't have to worry about those. It's not flipped. But in my parentheses, it's going to be x plus 4 squared. The next one is flipped. It's upside down, so I know it's going to be a y equals. And then it's not at the down 1, out 1, but it looks like it's going to be at the 2, which is going to give me the same chart as I was using up here. So it's just going to be negative 2. It's not moved left or right. It's just negative 2x squared. You're going to try the graphing on the bottom. Remember, 0.5 is just the same as 1/2. It's just a lot more work to try to change all the font sizes to make the fractions show up better. Try those and then compare them to the answer key.